problem, but this is an easier 10-point problem. Okay, so remember, we don't see a degree on top that's greater than a degree on the bottom. So go to slant asymptote and put NA. You still have to identify, hey, it doesn't exist. Your horizontal asymptote is going to come in this form from the number in the back. Y equals -1. Don't just write -1, y equals -1. Vertical asymptote comes from the bottom when you set it equal to 0, so x equals -4. So I get to come down below. I get to go to y equals -1, make a dotted line. I get to go to x equals -4, make a dotted line. And I get to grab the graphing calculator and let really the calculator do the majority of the work for us. So I have second plus 712. I'm plugging it in. The numerator, oh, and this is tough to plug in. So I start with 2 divided by x plus 4. And I do an ending parentheses. So I've put in parentheses the fraction, and now I subtract 1. Now to show my work, I'm going to do 2 to the right and 2 to the left of the vertical asymptote. So in this case, it would be -3 and -2, and -5 and -6. So for the purpose of time, let's see if I have those numbers. Let me see if I have those. Okay, so we are going to do right now, let me grab this. For the purpose of time, this would be -1, 0, -3, and -2. We could find those by going second trace value. Let's graph them. -3, 1, -2, 0. Then we have -5, -3, and -6, -2. Now, we're lucky here. We can already see that the 0 occurs at -2, 0. And we have a domain. It comes from the far left, and it keeps moving to the right until it approaches which wall? It approaches -4, jumps over, and goes from -4 to positive infinity. Range comes up from the very bottom, no limit how far down it goes, and it continues to move forward and moves up until it approaches the wall of -1, jumps over, and goes from -1 to positive infinity. As they go to the far left, what value is this approaching as you move to the far left? -1. And as you move to the far right, what value is it approaching? -1.